graph of a third-degree polynomial function is shown. The graph has integral x-intercepts. That means that these 3 points where it crosses the x-axis are all supposed to be whole numbers. So if they look like -1, 0, and 3, they are. Don't worry about them being slightly off. They guarantee that they're nice integers. And it passes through the point 2, -24, which is labeled there. Nice. Explain why the equation of the polynomial can be written in the form la la la. Well, whenever you have an x-intercept, there's a corresponding factor for it. If a curve crosses at x equals -1, that means one of its factors is x plus 1. Right? So that when you plug -1 into this piece, it comes out to 0. That's why the function hits 0 there. It's because this factor is causing it to happen. Here, where the curve hits 0 at x equals 3, there's got to be a factor that looks like x minus 3 that causes that to happen. And here in the middle at 0, you could write this as x minus 0 if you really wanted to, but technically it's just plain old x. So these 3 factors are the reason for these 3 x-intercepts. And on any polynomial curve, you can look at the x-intercepts and actually count them and know that each one of them is caused by a piece like this. And from that, you can kind of piece together what the entire function looks like. This polynomial must contain a plain old x, and it must contain an x plus 1, and it must contain an x minus 3. We get all that just from the x-intercepts. Now, on top of that, there could be some number out front here, and it could be a 2 or a 5 or a 10 or whatever. That wouldn't affect the x-intercepts, but it could mean that we had a polynomial that was significantly higher and had dips that were significantly lower, but it would still have the exact same x-intercepts, so it's kind of hard to pin down this number just from what we've been given so far. I put the question mark there, but technically what we're supposed to do is use a letter for it, and they chose C for constant. So we know all that about this polynomial just from its x-intercepts. And they've given us one more thing. They told us that this curve goes through the point 2, -24. That's good stuff, because with that we can solve for C. This is saying when x is 2, y comes out to -24. Well, we can use that here. We can say if our polynomial is -24, then that's got to be c times x plus 1 times x minus 3. That would mean -24 is c times 2 times 3 times -1, which would mean -6c is -24, and after a few moments of algebra, we get the c value must be 4. So now we know everything about this polynomial. We know it's got to be y, or p, equals 4 times x plus 1 times x minus 3. So you can reconstruct a polynomial if you know all of its x-intercepts and one other point, because you need that point to nail down your c value. So there's our polynomial. It's looking all nice, and then just when we thought we were done, they say, now put it back in expanded form, so now we have to multiply all this out. Oh, well, it's not too bad. X plus 1 times x minus 3 is going to be x squared minus 3x plus x, and then 1 times -3 makes -3, and then we multiply the 4x through. And we get 4x cubed minus 8x squared minus 12x, and that would be our expanded form.